The precise definition of a limit. In this section, you are going to understand the geometric meaning of two different notation, epsilon and delta. And we're going to talk about them. We're going to, do some examples where we need to find out suitable delta for given epsilon. Keep in mind, this is the first section where you are going to see, you know, this notation, which might be a little bit confusing at first. So when we started limit of a function, look at here. What is the limit of this function here? When x approaches to 1, the function value is approaching to 2. So that approaching value, that's just the intuition we are using by looking at a graph. But is there a way where we can guarantee mathematically that the limit of the function is 2 when x approaches to 1? So this precise definition is going to answer that question, because in calculus we need a mathematical guarantee way prove that the function limit stays exactly where we say it will. Okay, so that's the whole point. We need precision. Okay, let's start with this definition. At first, this definition looks not so simple, but I'll try my best to give you examples which might make sense. After that example, this definition will make sense. Okay, this is where you need to focus. The limit of the function when x approaches to c is L. Let's say this is the given information. So if you go back to this example, the limit of this function when x approaches to 1 is 2. So how do we write it? Limit of f of x when x approaches to 1 is 2 from the graph. It's very clear. Here, L is 2, x approaches to 1, the value of the function is given from the graph. What is the meaning of this statement? The meaning is, let's choose there are two positive numbers, epsilon and delta. Don't be confused, they are just notation for positive number. The meaning of this statement is the difference between the value of the function and limit. If the difference between them is small value like positive number epsilon, then we should be able to find out the small value delta such that the difference between x and c is less than delta. Keep in mind, this is the absolute value, so difference means it could be on the left side or right side. This is the value of y and this is the value of x. So this is precise definition. The meaning of limit is this one. But what does it mean? Let's look at them on the coordinate system. C is inside, C is the value. When x approaches to C, when x is very, very close to C, meaning there is an open interval like from C minus delta to C plus delta. Think about delta as a very small number. If you pick any input, any value of x from here, according to the definition of the limit, it should be guaranteed that the image of that supposed to be inside this interval on the y-axis. That is the meaning of a limit. Okay, that's the proper definition. I'm going to give you one example. Think about this. It's a challenging situation. For example, you work for a company and your company boss, she comes to you and she says, hey, this time I want you to make sure that our profit this year supposed to be 10,000 bucks. Our profit hits 10,000 bucks. That is the goal. Okay? She comes to you and she asks you, this is the goal, this is the target. And now you model your profit function using some linear, very simple function here. Let's say f of x represents profit function for your company, where x represents number of new customer you bring. So for each customer, there is a $500 profit. So if you bring 0 customer, then company is in loss, which is 2,000 bucks. Your boss wants to hit 10,000 bucks profit. How do you do that? So to get the $10,000 profit, you have to have, because this is your profit function, so you want this function supposed to be 10,000. Okay? How many customers do you have to bring to have the $10,000 profit? If you simplify this equation, 500x equal 12,000, and then if you divide both sides by 500, it would be 24 customer. So if you bring 24 new customer, you'll be able to hit that profit target. So, but in real life, that's not always possible. So your company boss, she says, hey, I want $10,000 profit, but you have margin of error 500 bucks. You can make 500 less or more, I don't care, but I need you to hit profit 10,000 bucks in year 2026. Okay? So now she's giving you the situation. She's saying, hey, I want you to hit 10,000 bucks as a profit. So L, that's the goal. That's what she wants you to hit. And she's giving you the margin of error 500 bucks. So that means you could have 500 less, which is 10,500 less means it's 9,500 to 10,500. So you can go, anywhere between 9,500 to 10,500. So C gives you this margin of error. So to hit that, to be in that margin of error, the question is how many new customer you supposed to bring. Yes, to hit the $10,000 profit, you must have 24 customer, but do you have room for error as a customer number? That is what you want to find out. So the value of delta means how many less customer or more customer I could bring such that my profit would be in this zone. So how do you do that? According to the definition of limit of this function when x approaches to 24. Why I'm choosing 24? Because I know for sure that 24 customer gives me $10,000 profit. So that's the reason we are using this 24. We already know for how many customer this function would hit $10,000 profit. And I did show you that calculation. So when x is very close to 24, the value of this function becomes 10,000. That is the limit of the function. Okay. Now, according to the epsilon delta definition, your boss allow you to have margin of error $500. So that is the epsilon we are looking for. So according to the definition of limit, for any epsilon, you should come up with some delta such that the value of any x from that open interval supposed to be inside this open interval on y-axis. So now we would like to find out what is the margin of error you have to recruit the new customer. And to find that thing, what you can do is you can start with this relation. how to find the value of delta, and these are some helpful steps. You can start with this inequality. You plug the value of f of x and L, and you try to go to this definition x minus c form. You start from here and you go to this inequality. That is that's supposed to be the direction for you to take. So let's go back to this problem. We have f of x minus L is less than epsilon. From here we would like to go to x minus c, which is 24. This inequality, whatever number comes here, that is the value of delta. That is the margin of error for you to hire new customer. So let's start here. Plug the value of f of x, which is 500x minus 2000. That's the value of the function, minus 10,000 less than 500. Okay, do the calculation. 500x minus 12,000 less than 500. You can factor out 500 because 500 is positive number, so you can always bring that outside. So that gives us 24 here. It's easy one. So now just divide both sides by 500, and that gives us x minus 24 less than 1. You see, that is what we're looking for, x minus 24 less than what? 1. So the margin of error for this example for you is one customer. You can have one less customer or one more customer. If you do that from your target, which is 24, you could have anything between 23 to 25, and that will help you to meet that target for your company. So always try to take this precise definition as a challenge. For any epsilon, can you find the delta such that any value from that interval on x-axis goes inside the interval on the y-axis? Okay, so let's look at some more examples here. This one, look at this one, this example. Use the given graph to find the largest value of delta. Whenever you have given a graph, as you can see here, anything in between from 4.85 to 5.15, the image of that input goes inside this interval on the y-axis. So the largest value of delta is always the minimum distance from the center to the left or to the right. In this case, if you focus here, the distance from 5 to 4.85 is 0.15, and distance from 5 to 5.15 is also 0.15. So both of them, they have same distance from the center. So if they had a different distance, and then you always choose the minimum one. So the value of delta would be 0.15. Either you go to the left 0.15 from 5 or right 0.15 from the 5. The image of your input by using this function always stays inside this interval on the y-axis. So the largest value of delta is 0.15. Let's go to next problem. For the given function, linear function 3x plus 5, the limit of the function is 20. The value of c is 5 and epsilon is 0.15. You would like to find out the interval on the x-axis such that this relation holds. Keep in mind, you have this f of x minus L is less than epsilon. You want to find out x minus c less than delta, this relation. Okay, how do you do that? Plug the value of f of x, which is in this case 3x plus 5 minus L 20 less than epsilon, which is 0.15. Try to simplify this such that you are going to get this inequality. So 3x minus 15 less than 0.15. You factor out 3, x minus 5. This is very simple type of function. We're going to see some you know, other examples where the function is not so simple like this. So divide both side by 3. You can divide both side by positive number and it's still you have this inequality. Point, if you divide 0.15 by 3, it's 0.05, right? So x minus c is less than delta. So the meaning of this is around 5 here, you can go 0.05 unit to the right, which is 5.05, or to the left. So if you subtract 0.05 from 5, it would be 4.95. So you can go anywhere from this point to this point, and still the image of that input would be inside this interval on the y-axis. Make sense? So the interval they are asking you here is 4.95 to 5.05. Okay, so what is the value of delta here? The delta is the minimum distance between from 5 to either left side or the right side. Keep in mind, always take minimum one. But both of them, they have same distance. So the value of delta you can choose is 0.05. In this case, it's a 0.05 because both of them, they are on the, they are at the same distance from the center. So these are some linear functions I use here. In next video, I'm going to choose some, non-linear function for finding a delta.